Hey everybody, welcome to the week of May the 4th through 7th. Crazy to think that we are this far into distance learning, isn't it? You guys are doing awesome. I'm so proud of you. And just wish that we could be in person, but since we can't, I love giving you these videos and teaching you like this. So this week, our key concept that we are going to be going back over is division. Guilford County says, and I do too, and so does the state of North Carolina, that multiplication and division are one of the major works of fourth grade. Technically, they're one of the major works you're going to do for the rest of your life. But long division, something new that you've learned in the fourth grade, is something that's really, really important for you to know well for you to carry into the fifth grade. So I'm going to go back over a couple of division strategies that we used earlier this year. One is called the box method. One is the standard algorithm. Now, if your moms and dads are hearing this, I want them to know that the state of North Carolina does not mandate that students know the standard algorithm until they get to middle school. In the fourth grade, one of the things that they encourage is for us to use visual division, like place value dots. Our kids really didn't love that. So the box method is a great segue from that visual division to the standard algorithm. And most of the kids in the classroom really loved the standard algorithm. Loved the box method. A few loved the standard algorithm. I want you to think back to when we did division and think, which one of these two was your way? Which one did you do really well? And that's the way that I want you to practice today. So what we're going to do is we're going to divide 743 divided by 5. We're going to use the standard algorithm and the box method. I'm going to do them side by side so that you can see exactly what to do. Now, in division, we have 4 steps that we follow over and over and over again through each place value until we're done. So basically, when we divide, we're taking a large number and we're trying to figure out how much would each person get if I divided it equally among 5 people. So I'm wanting to take the number 743 and divide it 5 ways, 5 fair shares. And I want to know what the answer is. That's called the quotient, as well as if there's anything left over, and that's called the remainder. When we divide, we do these steps over and over again. And in class earlier this year, we learned a little song that went with these steps. And it went to the tune of head, shoulders, knees, and toes. We talked about the first step being to divide. The second step being to multiply. The third step being to subtract. And the last step being bring over or bring down. And we sang it kind of like this. Divide, multiply, subtract, and bring over. Divide, multiply, subtract, and bring over. Long division goes around and around. Divide, multiply, subtract, and bring over. Now in standard algorithm, we bring down, which you'll see in just a few minutes. But in the box method, we bring over. So let's divide using the box method. So I'm going to take 743, which is my dividend. That's the large number I'm trying to share equally. And I'm going to write that number just like it would look in a place value chart. I have 7 hundreds, 4 tens, and 3 ones. And I want to see how much I will get in each group if I divide it equally into 5 groups or 5 fair shares. All right, the first thing I'm going to do is I'm going to divide. I'm going to think how much or how many will each group get if I have 7 hundreds and I give one of those hundreds equally to 5 people. One easy way to do this is to skip count by 5 and see how close I can get to 7 without going over. So let's skip count by 5. 5. If I go another 5, I get to 10, and that's too many. So 5 can go into 7 one time. That's my first step. I just divided. My next step is multiply. I'm going to multiply the number that goes in each fair share times 5. When I divided 700s, there was only enough to give each group 1 if I had 5 groups. And 1 times 5 is 5. So of the 700s that I started with, I've given away 5. And I have 2 left over. 2 is the remainder in my hundreds place. Well, I'm going to turn those 200s into 20 tens. So I'm going to move those 200s into the tens place. I had 4 tens. I brought over 20 tens. And so now I have 24 tens. And so I want to figure out now how many each group is going to get if I share 24 equally into 5 groups. So once again, I'm going to skip count by 5. 5, 10, 15, 20. The next would be 25. That's too many. So 5 goes into 24 4 times. Of my 24 tens, I can use up 20. 4 times 5 is 20. My next step is to subtract. I had 24 tens. I've shared 20 tens equally, and I have 4 tens left. Well, I'm going to bring those over to the next box, to the ones place. I had 3 ones to start with, and I have 4 tens left, so I know that's 40 ones. And I've brought those to my ones place, and now I have 43 ones that I need to divide equally. So I'm going to skip count by 5 again. See how many times I can skip count by 5 to get to 43 without going over. 5, 10, 15, 20, 25, 30, 35, 40. I can't go any higher. So I counted by 5 8 times. So I can share 43, or I can divide 43 by 5 8 times. And when I do that, I'm now going to multiply 8 times 5, which is 40. I've used up 40 of my ones. Now I'm going to subtract again. When I subtract 43 minus 40, I have 3 left over, and this is my remainder, and it's going to shoot out of my box and come up here and show as my remainder. So the quotient to 743 divided by 5 is 148, remainder 3. The quotient is 148 and the remainder is 3. Now I always want to do a check. So I'm going to take my quotient, 148, and I'm going to multiply it times 5. And then I'm going to add my remainder to whatever I get. 8 times 5 is 40. 5 times 4 is 20. 20 plus 4 is 24. 5 times 1 is 5. Plus 2 is 7. And now I'm going to add my remainder of 3. 740 plus 3 is 743. So I was correct. I ended up with an answer that was the same as my dividend. All right, the standard algorithm. Same exact thing as the box method. Lots of you said, I'm not ready for the standard algorithm, and that's completely fine. If this box method is your way, keep doing it. It's really easy to tell when you're done in the box method. It looks a little bit like the place value chart that we used earlier this year. So hey, if that works for you, go for it. Standard algorithm, same steps. I'm going to divide 5 into 7. 5. It can go 1 time. Now I'm going to multiply. 1 times 5 is 5. Now I'm going to subtract. 7 minus 5 is 2. Now I'm going to bring down the next number in my division problem, which is a 4. Only bring down one at a time. Now I'm going to divide, make my little division sign again. Now I'm going to divide 24 divided by 5. So I'm going to skip count by 5 again. 5, 10, 15, 20. That's 4. I put the number of times I skip count at the top. Now I'm going to multiply. 4 times 5 is 20. Now I'm going to subtract. 24 minus 20 is 4. My next step is to bring down. And I want you to notice something, guys. Every time I bring down and I divide again, it's exactly what I divided over here in the box. I first divided 7 by 5. The next number I divided was 24 divided by 5. And the last number I divided was 43 divided by 5. So you can see how rather than having to take this straight down and remember what to bring down, doing it in the box lets me see, especially when I'm done. So my last step in the standard algorithm is to say 43 divided by 5, 5, 10, 15, 20, 25, 30, 35, 40. That's 8 times. 8 times 5 is 40. 43 minus 40 is 3. 3 is my remainder. Of course, I would check it in the same way. 2 different methods, very similar, and I got the same answer. Well done. Now, just a quick reminder of something that happens sometimes when we're dividing. Let me draw another box over here. Sometimes, and this kind of stumped a few of us earlier this year, sometimes when we divide, we cannot divide that first number by 3 because there's no way that we can take one thing and divide it into 3 equal groups. We'd end up getting a fraction. And so when that happens, we can do one of two things. We can either just take this line away and say, hey, instead of it being 109 tenths, I'm going to call this 19 tenths, and I'm just going to divide 19 divided by 3. When I skip count by 3, 3, 6, 9, 12, 15, 18, it can go 6 times. 6 times 3 is 18. Subtract, and I have 1 left over. 110 left over. That can go into my ones place. And now I have 12 ones. 3 goes into 12. 4 times. 3, 6, 9, 12. That's evenly. 4 times 3 is 12. And I have no remainder. So this can happen. Some of you are more familiar, more comfortable with doing it like this. And this works too. You said, how many times can 3 go into 1? None. So we put a 0 up here. 0 times 3 is 0. Anything times itself is 0. 1 minus 0 is 1. And then I move that 1 over, and now I have 19 tens. 3 goes into 19 6 times. 6 times 3 is 18 with a remainder of 1. That moves to the ones place, and now I'm dividing 3 into 12, which is 4, and a remainder of 0. So you can either do it this way or this way. It does not matter. You can either say, hey, I know 3 won't go into 1, so I'm just going to get rid of that and think, how many times does 3 go into 19? Or you can say, hey, 3 won't go into 1, that's 0, and do it this way. It does not matter. That is up to you. You're working on a problem set today. This is my encouragement to you. Last week, some of you guys went really fast through your multiplication. And it was probably because you were like, I've done this before, it's easy, but it's been a while. So before you submit your answers, how about you check them on a calculator, and if they're wrong, go back and fix them. I do want to see your work when you submit it. I want to make sure I see you doing either the box method or the standard algorithm, whichever one you want to do. I want to see your work. But I want you to check your answers, and if you get them wrong, please, please, please go back and fix your mistakes. All right. I can't wait to see your work. Talk to you later.